What are magmatic deposits? Magmatic deposits are mineral deposits that form through the crystallization of magmatic fluids, which are typically associated with the cooling and solidification of magma bodies. These deposits are important sources of many valuable minerals, including copper, nickel, platinum, chromium, titanium, and rare earth elements. Magmatic deposits can be classified into two main types: plutonic deposits and volcanic deposits. Plutonic deposits form when magma solidifies within the Earth's crust and cools slowly, allowing time for large crystals to form. Examples of plutonic deposits include the Bushveld complex in South Africa, the Stillwater complex in Montana, and the Norilsk-Talnak deposit in Russia. Volcanic deposits, on the other hand, form when magma is erupted onto the Earth's surface as lava or ash and cools rapidly. These deposits typically have a more fragmented texture and are associated with smaller mineral grains. Examples of volcanic deposits include the Sudbury Basin in Ontario, Canada, and the Pueblo Viejo deposit in the Dominican Republic. Magmatic deposits can also be classified based on the mineralogy of the deposit. For example, deposits that contain significant amounts of sulfide minerals are called sulfide deposits, while those that contain oxide minerals are called oxide deposits. The formation of magmatic deposits is a complex process that involves the concentration of metals and other elements within a magma body. This concentration can occur through a variety of processes, including fractional crystallization, assimilation of country rock, and fluid immiscibility. Magmatic deposits are typically found in areas where volcanic and plutonic activity has occurred. These areas can be identified through geologic mapping, geochemical surveys, and geophysical techniques such as magnetic and gravity surveys. The extraction of minerals from magmatic deposits can be challenging due to the complexity of the deposit and the high temperature and pressure conditions under which they formed. However, advances in mining technology and the use of innovative techniques such as high-pressure acid leaching have made it possible to extract valuable minerals from these deposits. In conclusion, magmatic deposits are important sources of valuable minerals and are formed through the cooling and solidification of magmatic fluids. The study and exploration of these deposits are important for understanding the Earth's geologic history and for identifying new sources of mineral resources. How is the formation of magmatic deposits? The formation of magmatic deposits is a complex process that involves the concentration of metals and other elements within a magma body. This concentration can occur through a variety of processes, including fractional crystallization, assimilation of country rock, and fluid immiscibility. Fractional crystallization is one of the most important processes involved in the formation of magmatic deposits. As magma cools, minerals start to crystallize out of the liquid in a specific order based on their chemical and physical properties. The first minerals to crystallize are typically those with the highest melting points, such as olivine and pyroxene. As these minerals settle out of the magma, the remaining liquid becomes enriched in other elements, including metals like nickel, copper, and platinum. Over time, this process can lead to the formation of large magmatic deposits that are enriched in valuable metals. Assimilation of country rock is another process that can contribute to the formation of magmatic deposits. As magma intrudes into the Earth's crust, it can melt and incorporate surrounding rock formations into the magma body. This process can introduce new elements into the magma, including metals that were not originally present. As the magma cools, these metals can become concentrated and form a magmatic deposit. Fluid immiscibility is a process that occurs when two different liquids that are immiscible, or do not mix together, are present within a magma body. This can occur when the magma contains two different types of fluids, such as a sulfur-rich fluid and a silicate-rich fluid. As the magma cools, these fluids can separate into distinct phases, with the sulfur-rich fluid becoming enriched in metals like copper and nickel. This can lead to the formation of sulfide deposits, which are important sources of many valuable metals. The location of magmatic deposits is closely related to the geological setting in which the magma body formed. Plutonic deposits, for example, are typically associated with large magma chambers that solidify slowly within the Earth's crust. These deposits are often found in areas of high tectonic activity, such as subduction zones or continental collision zones. Volcanic deposits, on the other hand, are typically associated with smaller, more rapidly cooling magma bodies that are erupted onto the Earth's surface. These deposits are often found in areas of active volcanic activity, such as island arcs or rift zones. In summary, the formation of magmatic deposits is a complex process that involves a variety of different mechanisms, including fractional crystallization, assimilation of country rock, and fluid immiscibility. The location and composition of these deposits are closely related to the geological setting in which they formed, and their discovery and extraction are important for the development of mineral resources and our understanding of the Earth's geologic history. What is the importance of magmatic deposits? Magmatic deposits are of great importance as sources of many valuable minerals, including copper, nickel, platinum, chromium, titanium, and rare earth elements. These minerals are essential components of modern technology and are used in a wide range of applications, from electronics and transportation to construction and renewable energy. Copper, for example, is an essential component of electrical wiring, plumbing, and many other industrial applications. It is also used in renewable energy technologies such as wind turbines and solar panels. Nickel is an important component of stainless steel and is used in many other alloys. Platinum is used in catalytic converters for automobiles and in jewelry. Chromium is used in stainless steel and other alloys, as well as in the production of pigments and chemicals. Titanium is used in aerospace and defense applications, as well as in medical implants and consumer products like sporting goods and jewelry. Rare earth elements are used in many high-tech applications, including electronics, batteries, and renewable energy technologies. In addition to their economic importance, magmatic deposits are also important for understanding the Earth's geologic history. The study of magmatic deposits provides insight into the processes that have shaped the Earth's crust and mantle over millions of years. By analyzing the composition and structure of magmatic deposits, geologists can reconstruct the history of magma generation, crystallization, and eruption. This information can also be used to understand the tectonic history of a region and to identify areas of high mineral potential. The extraction of minerals from magmatic deposits can be challenging due to the high temperature and pressure conditions under which they formed. However, advances in mining technology and the use of innovative techniques such as high-pressure acid leaching, HPL, have made it possible to extract valuable minerals from these deposits. In summary, magmatic deposits are of great importance as sources of many valuable minerals and are essential components of modern technology. They also provide important insights into the Earth's geologic history and are important for identifying new sources of mineral resources. The study and exploration of magmatic deposits are critical for economic development, scientific research, and environmental stewardship. Please don't forget to subscribe to my channel and turn on notifications.